Hello students, in this video we'll discuss the chain rule. If we're given a function f of x and y, and suppose that x is a function of t and y is a function of t. Then, if this is the case, then we can think of a configuration like this. We have z, which depends on x and y both depend on t. And so z also depends on t. And so what the chain rule will do is the chain rule will tell us how z depends on t. So the first form of the chain rule states that dz dt, if this is z equals f of xy, is partial f partial x dx dt plus partial f partial y dy dt. So we see over here that the idea is that if I have a dz dt, if I think about canceling out these dx's and canceling out these dy's, I'll have df dt, so it has the exact right form. So let's see an example of this. If, for example, we had that f of x, y was our variable z, and this was equal to x squared plus x times y, and suppose that x was equal to e to the t and y was equal to sine t. Then from this we can use the chain rule to say what's dz dt? Well, dz dt is going to be dz dx, so that will be a 2x plus y, where x is equal to e to the t and y is equal to sine t, times the derivative of x with respect to t. The derivative of e to the t with respect to t is just going to be e to the t, plus partial f partial y, that will just be an x, where x is equal to e to the t and y is equal to sine t, times the derivative of y with respect to t, which will just be cosine, because y is equal to sine, so cosine of t. And so now we can put this together and simplify, so dz dt is going to be equal to 2 e to the t plus sine t e to the t plus e to the t cosine t. And there is our solution. Now, the chain rule can also extend to functions that have more independent variables. So if, for example, we had z, which was equal to f of xy, and suppose we also had that x was equal to a of u and v, and y was equal to b of u and v, if this was our setup, then we would have z, which depends on independent variables x and y themselves depend on independent variables u and v. So what would the chain rule tell us in this case? The chain rule would tell us over here that partial z partial u would be partial f partial x partial u plus partial f partial y partial u, and likewise partial z partial v would be partial f partial x partial v plus partial f partial y partial v. And now we can notice that they have the right form. If we were to cancel out this dx here, I would see that I have df du. If I cancel out this y here, I would have df du. So both of those terms have to be present to do the full derivative. So these are our chain rule. Now we should also point out what we're doing here. When we're doing the derivative of f with respect to x, we're treating y as a constant. When we do the derivative of x with respect to v, we're treating u as a constant. When we do df dy, we're treating x as a constant, and when we do dy dv, we're treating u as a constant. So understand what we're treating as a constant is very important for the chain rule. So let's see an example of this. So if we had something like this, so if our function z was equal to e to the x times the cosine of y, and if x was equal to u times v, and if y was equal to u squared minus v squared, then what would dz du be, for example? Dz du would be dz dx, which will be e to the x cosine y times cosine y. That's my dz dx. And I'm going to multiply that by dx du. So dx du is just going to be a v, plus I have to do df dy, So df dy is going to be e to the x cosine y times negative sine y by the chain rule. And then I have to do the derivative of y with respect to u, and that'll just be a to u. Now what we need to do is everywhere we see an x in this expression, I'm going to have to fill in what? I'm going to have to take uv and fill it in for x, and u squared minus v squared and fill it in for y, and then my end result will be a function, so this dz du is going to be a function of u and v once we plug in what x and y are equal to in terms of u and v. Again, when we're doing the chain rule, we use the chain rule. The rule for it is relatively straightforward, but understanding which variables are constant and which variables are fixed is very important, and that's why this constraint notation is oftentimes helpful for us. Thank you very much.